We have already told mechanism of nucleophilic substitution reactions are very important. Actually, it's an FAQ. You can see here the same question is asked in different ways. Briefly discuss the mechanism of SN2 reaction. That is one question. The same question is asked with another aspect. Why inversion of configuration take place in SN2? So let us see. In this we have to know what is inversion of configuration, what is SN2, and how that reaction takes place. But I think all these names in SN2 reaction is familiar to you. S stands for substitution. You know what is a substitution reaction. That means a reactant, a particular reactant is replaced by another reactant. And then nucleophilic. You know what is a nucleophile? Something that is nucleus loving. That means an entity that carries a negative charge in it, or an entity that carries electrons in it, that makes it negative in charge. That is a nucleophile. And then bimolecular. It is a bimolecular reaction. So this is the mechanism of SN2 reaction. And in this reaction, we are explaining the reaction between the nucleophile OH minus. This is the nucleophile here. Hydroxide ion is the nucleophile. And then the reaction between methyl iodide CH3I. This is CH3I. So methyl, a reaction between methyl iodide and OH minus ion. And so during this reaction, so here the methyl iodide is explained in a 3D arrangement which you have already learned in your class 11. So here we have a solid wedge. This different hydrogen atoms are explained in a 3-dimensional manner. This hydrogen with the solid wedge represents the bond that is coming out of the plane of the board. That means this hydrogen stands just like if carbon is on the board, this hydrogen comes out of the board. And then this hydrogen that is bond shown with a single line, that is in the plane of the board. And this hydrogen that is connected with a dashed line, that is going behind the plane of the board. Okay, so that is the 3-dimensional arrangement that is shown here. So during the reaction, the hydroxide ion approaches from the rear side. That means from the back side of this methyl iodide. Okay. During that process, here we have iodide attached with the methyl group, and then when it is coming from this side, this hydroxide ion also comes to attach with the carbon that is present at the center. During that process, this hydrogen atoms will adjust itself and will give a way to hydroxide ion to get attached with the carbon. And then it moves to the transition state. That means during the process of attachment of the hydroxide ion, you can see iodide ion is still attached with the carbon. There is a time, you know that transition state is momentary. It is short-lived as well as it is highly unstable. Whatever be the transition state of any reaction is highly unstable, and it is within a very less time it will be acting as it is. Okay, so in this case you can see carbon is bonded with 5 atoms, 3 hydrogen atoms and 1 hydroxide ion and 1 iodide. Okay, so it is not possible. So the moment hydroxide, so 2 processes are taking place in the transition state at the same time. One process is the attachment of hydroxide ion, and the second process is the detachment of iodide ion. So this is when we look into the transition state of this SN2 mechanism. Actually, what is happening? Hydroxide ion is partially bonded to the carbon. At the same time, iodide ion is partially in a way of leaving this carbon. Okay, and then the transition state happens for a moment, for some time, and then what happens? This hydroxide ion is also a negative charge, and this iodide ion is also carrying negative charge, and a push from hydroxide ion expels iodide ion out. Okay, so this iodide ion is out, and now what happens? ion here, these hydrogen atoms will be compelled to readjust itself into the opposite direction. See, it starts here like this. Carbon and hydrogen atoms are aligned like this and the iodide ion is here. When hydroxide ion got attached to the back side of this carbon atom, what happens? These three hydrogen atoms are just went to the opposite direction. So we will compare it with this change in configuration. We compare it with when a storm comes or a wind comes during the rain, our umbrella just goes out, just move from the in to out. This umbrella goes up like this, just get turned up. In that way, this is known as, can also be told as an umbrella inversion. Like it is just got turned upside to the other side. Okay, and this is also known as Walden inversion. A kind of inversion of configuration takes place here. Okay, this was the original configuration and this is the present configuration after the attachment of the nucleophile, and this is known as inversion of configuration, stereochemical inversion of configuration. I think we have answered both the questions. Okay, so this is the explanation. How can you briefly explain SN2 mechanism is this, and at the same time, how can you explain the inversion of configuration that takes place during SN2 mechanism is this. This is the inversion of configuration, and this inversion of configuration will mark SN2 reaction. Okay, that means if anytime some other question may come, you want to recognize which type of a reaction is this. Is this an SN1 reaction or SN2 reaction? Then no doubt look into the stereochemistry or stereochemical aspect of that particular substrate. If it is getting an inverted product, this will be an SN2 reaction. SN2 reaction stands with a special aspect of inversion of configuration. Okay, that's it. During the transition state, you can see also here these carbon atoms and these hydrogen atoms are in 120-degree angle. It will align itself. So first, the approach of hydroxide ion from the rear side, from the back side of the carbon atom, and in the next stage, that means in the transition state, which is a very highly unstable state, this hydroxide ion and iodide ion both will be in a position that they both of them are attached with the carbon atom. Okay, so a push from the nucleophilic side will detach iodide ion, and so it will be this methyl iodide will be changed into methanol and iodide ion. That is what is happening in SN2 reaction, and this is the mechanism of SN2 reaction. I hope you have understood. Thank you very much.